Today I will be talking how to use refactoring to create something that you can actually work with. Today, especially in the day of LLMs, we are faced to work with unmaintainable code bases. But first things first. My name is Bojan, as you already know. I've been working with software from 2012. I worked in a bunch of startups, and currently I do a bunch of contract work for clients. During my career, I have created tons of bad code. I have written some good one, but bad code outweighs it. And I had the opportunity to work with really ugly code bases. So I'll be sharing some tips on how to make your life easier. This is my little assistant. He's been with me for a year, so applause for him. Now, let's start from the big thing. Who here has worked with a legacy code? Who here loves legacy code? I can see the difference. Now, legacy code is not a very attractive thing. But before we start with how to make it a bit better, let's take a time to appreciate the legacy code. Because by definition, a legacy code is something that is creating value. It's being used by people. It has been validated by the business that it actually works. If we're all hoping that one day our code will become a legacy code. If nobody is using your code, it's not a legacy code, it just gets forgotten. So we appreciate the legacy code, no matter how horrible it might be. Now, we all want to make a beautiful code. And in our mind, we have an image. I'm going to refactor the code base, and it's going to be beautiful. And I won't have any single problem in my life. It does not work like that. As my assistant tells you, it's like washing the dishes. Every single day, you need to make a conscious effort to make a code base better. If you forget about it, you will come, and it's going to be a huge pile of bugs, horrible decisions you have made, and at a certain point, you just give up on it. You try to pretend it's going to get better on itself. It won't. So I would like to encourage you to do a little bit of work on making code base better every day. Now, there are many reasons we would like to refactor code. And sadly, there are much less reasons why business will allow us to refactor the code. If we are really good at what we do, there are many things that are competing for our attentions. And out of those, we need to have some performance issue if we want to refactor. Aesthetics does not go into it. We cannot go to a manager and tell them, our code is ugly. They will not care about that. So, have a real pain point. After the performance, we have bugs. And since we all use beautiful assistants, called LLMs, that create enormous amounts of bugs, sometimes we might want to take that output and transform it into something that people can work with. So if you have a certain piece of code that is constantly creating bugs, instead of fixing the bugs, it's worth going into and transforming it into something nice. And second, actually the third, we might create architecture, and it might be super good and beautiful, and it might be horrible. But over the time, the business will evolve. Users will come with new requests, and we will have to anticipate those. And predicting future is impossible. So no matter how good the decisions, at one point, you will have to take approach at the overall project structure and say, okay, this needs to be changed, because it's taking us more and more time to create new features. And our managers are getting more and more angry with us. Okay. We all work with the code. And contrary to the popular belief, coding is a very small part of our time. And the most complicated thing that you need to solve when you are working with a complicated code base and you want to improve it, it's the other people. They are the ones who create horrible code. They are the ones that destroy the beauty of our code base. And they are the ones we need to convince to let us work on the issues. Now, before you actually want to do the refactoring, there is some maintenance to be done. First one is to get approval from the management. And I'm going to give you some questions that they are going to ask you. So if you prepare this in advance, there's a very good chance that you're going to get a green light from your managers. First thing, when you come to a manager and say, I want to improve the code base, they're going to ask you, how much money do I need to pay for that? If you do not have a good answer to that, they will give you something else to work on. Second question is, how long is this going to take? For some insanely complex code bases, it might take several months. For something smallish, it may take a few days. The smaller the amount of time needed to change, you have better chances of getting approval. And what are the actual benefits? This is something you need to articulate. If you're very happy and you don't have managers, you always need to know what is the actual benefit of this. Making you happy is not really high on the list of things that are going to make it pro. Now, refactoring has a very simple flow. It's highly complex, but it has a very simple flow. So, before you start refactoring, you need to put on your Indiana Jones hat and do code archaeology. You need to try to understand the reasoning that went into this. And what does this piece of software actually do? A bunch of the time, we were using a piece of software in a way it was not supposed to be used, which was one of the issues. Or maybe it has some side effects. Something else is calling it or depending on it. You need to understand all of that. In the age of LLMs, this is even harder, because you might have 10 different libraries used for making a connection with Redis. There may be some logic that does not make logic at all. So trying to understand what is the ground status of everything is very important. Now, for example, I would never ever advise you to take a whole code base, throw it into LLM, and get asked it, what does this thing do? That is not a good approach. You are a programmer. You need to understand architecture, decision, the effort that went into that code. And you might be able to solve it quickly with coding assistance. But the thing is, you're not paid just to write code. You're paid to understand. And working on the code itself, I often learned a bunch of new things. I get better as a programmer when I see how somebody else approach the problem that I'm solving currently. Always try to learn. It's not an easy approach. It's much easier to just throw it into LM. Don't do that. Like, it's a short-term solution that's going to come to bite you. Now, when you have your understanding of the code base, next step is the one that I'm going to be repeating constantly. Tests. It's very rarely that you come into a code base and it's fully covered with tests. Try writing some tests to validate your hypothesis, even if you have some understanding of what is happening there. Always write tests and let them tell you what's there. Usually, when you're starting with refactoring, you're not going to be able to write unit tests, because code base is a mess. Try to write tests around it. Try to simulate the system that are interacting with it, but have something, because it's very easy to break stuff. And if you have tests, and I know lots of people don't like writing tests, but they are very useful. I have spent 5 years of my life not writing tests, and I want those 5 years back. Because if you don't have tests, the client is going to call you at 5 in the morning, sometimes even earlier, and I like to sleep. So, tests. Now, the next thing is you don't even have to do anything special, but as you're reading through the code, put comments there for yourself, because sometimes you might interrupt your flow. And when you come back to it, it's going to be like you're a new person. So make a gift to your future self, to somebody else who will be working on it. Try to write down what is happening, what is new in the code. Names are very important. I have worked on a code base when one researcher used variables A, B, C, D, E, F, G until Z. And when he got to Z, I was very happy because I wanted to see what he's going to do. His next variable was named alpha, beta, gamma, theta. Don't do that. Try to name your variables and functions sensibly. Modern IDEs, JetBrains, VS Code, you have right-click and rename. They're gonna do all the stuff. Like in 2000, at the beginning, it was much harder to do. Now it's just right-click, use that right-click. Name it sensibly so you understand what's happening there. I'm gonna show you one sentence here. If X is none or X is not none. This is nonsensical, it's always gonna be true. And you're gonna forget this line of code by the end of the day, if not faster. But this line of code written in Python is equivalent to the most famous line in English language. To be or not to be, and we all remember this. So how you name things, how you use them, it's very important. Because I don't have a good memory. If something is named x1, x2, and function is adding things, I will not remember it in 15 minutes. So I need to, for my own sake, name things as they should be. It sounds very simple. Naming is extremely hard. It does not get easier with age. Make things small. I have worked with a code base that had one function that was 10,000 lines code. I'm not kidding. It was absolutely a mess to work with. Make the function as small as possible, then group it up, then group it up again. So if you have a function that's like 5 or 6 lines long, that is very good. You want to be able to take a look at the code base and understand at the same moment what is happening here. Longer it takes you to understand, harder it's going to be to change things. So, and again, I'm going to underline this. You spend much, much more time reading code than actually writing. Don't optimize for writing, optimize it for reading. And now that we have improved readability, we go back to testing. As I said, modern IDEs are very good at refactoring things, splitting it to smaller functions, renaming it. But in your ultimate infinite wisdom, some of the previous developers, or in my case, me 2 months ago, might have decided to do something fancy with evaluations or something that you should not do that IDE did not catch. Every time you change something, write a test. Then you click those tests and you know if you broke something. And you want to know if you have broken something as soon as it happens. After we have improved readability, we decide what do we want to change. More often than not, you're not going to be able to change the entire code base. Find a single segment that's extremely problematic, either from the performance issue, either from the readability standpoint, either because it's generating the bugs. Isolate it. And the first thing you're going to do when you isolate it, write tests around it. Try to mock it around. Python is really good for mocking stuff. Mock everything around it, basically take it out of the code base, and then start working on it. Don't try to split it up or anything until you have made a really good fence out of tests. Okay. I was talking about optimizing performances. Here, you're going to need to use one of the most powerful things you have, common sense. It's in very short supply. Don't spend time optimizing things that don't need to be optimized. There is a really good saying, premature optimization is the root of all evil. It is very true. And think about how it's used. Like if you have a business function that generates a report once per year and it takes 12 hours, but everybody is super happy to wait for it, you could probably make it run in 20 minutes, but you will spend 2 weeks. Don't do that. Like, see, is my time actually worth it? Because more often than not, your time is much more expensive than those 12 hours that you're going to save. On the other hand, you might have a small function that is used by the entire company. You have millions of users, and you can probably make it faster by 20 milliseconds, which is nothing. We don't even notice that amount of time. But because it's used so much and has such a high impact, it's going to save tons of money. Work on things that matter. And Sadly, the really good metric of what matters is how much money it generates. I wish it wasn't like that. Now, how do we got the code to a really, really good state. And the question we're going to be asking ourselves, how do we keep it like that? It is not easy, because I know myself. I'm sometimes lazy. I'm just gonna commit stuff to the main, and things are going to break. Don't do that. Make it as hard as possible for you to create a bad code. Make a system, make checks against yourself. And once you onboard new engineers, new programmers, talk with them and make guards. First thing first, there is a really good discussion about should we use tabs or spaces. It's a useless discussion. Like, you can spend tons of time arguing about which coding style is better. Try to automate it. I like to use RAF. Use something that's going to format code base. Good code base is not something that looks like it was written by hundreds of engineers. It's somewhere where you have hundreds of engineers, but it looks like it was written by one person. Biggest thing is you need to reduce the cognitive load, because you will be running around that code base all the time. And you're not going to be able to keep it in your head. So always try to automate things. As I mentioned, RAF is a good thing. There are a bunch of new tools, and they're coming out every day. Go and listen to the talks about them, and then try to implement them. The list of tools I'm going to give you are not the holy grail. It's the how you implement them, the process. Sometimes you're going to have to add exceptions. Do that, but understand why are things like that. And make a note for future people, because if you had a really good reason to make an exception in automated tooling, you want people in the future to understand that. You don't want them to change it and then break stuff. So, pre-commit, a wonderful thing. Make it impossible for you to commit horrible things to the repository. Go to some popular open source project. Take a look at their pre-commit hooks. What tools are they using? How are they ensuring the quality of the code? And just steal stuff from them. It's open source. CI/CD pipelines. Now, as popular it is to push things on the master, there is a very good reason why we use GitHub repository. When I started working in 2012-13, I did not use Git. I would go to the server, open Vim, and directly change stuff in production. I have learned very quickly why that is bad. Do things in a way that makes it harder to touch the production. So you're going to have staging, you're going to have testing. Or hopefully, before your code hits the end user, there are going to be several checks. Run always tests. Some tests are super slow, like everything that has to work with database. That is going to be slow, which is okay. You don't have to run those type of tests and pipelines on every commit. But when you create a PR, run entire suite of tests. Make sure that you don't break anything. There's going to be a bunch of resources that you're using. I work with AWS a lot. AWS loves to take your money. They make everything insanely expensive and really hard to calculate what's happening there. So there are stuff like local stack that emulates that. There are tools, use them, mock things, but sometimes test them on the real thing. Because I'm going to underline, production, when it breaks, it makes a lot of stress for everybody involved. So make it as hard as possible to break. Code reviews. This is how I learned to code. Find a really good developer and make them review your code. Every organization is going to have a different standard, how they make a code review. And That is okay. Learn what is standard in your company. Try to make a description, motivation of what is happening there. Don't make insanely huge code commits. I have learned over the years that bigger the code commit, the code you're trying to merge, faster you're going to get approval. Like once you go over 5 files, everybody's going to say good to merge. Nobody's going to look at it. Make it smaller. Make people look at your code. Now, and this is the part where I try to be not overly critical of LLMs, because I do not like them. People will commit changes made with LLMs. And LLMs love to modify tons of files. So you will have to, for example, switch from integer to float. They will make a 500-line commit and modify how you work with the database. And people commit that. For me, doing a code review, it's basically social contract. I'm going to be respectful of your time and effort you put into code. But on the other hand, I expect that you understand all of the things you have wrote, and you're able to make changes. If you submit a huge line of code, and I go over it, I'm going to give you some advice how we can improve it, and we can have a discussion. But if I say, okay, let's try to change how we are communicating with database, and the next thing you commit is entire code that you have committed completely changed, it's not going to function. If you are using LLMs, try to keep them as small as possible. You're working on a function. Okay, keep it inside just that function. Use it as a helping aid. Okay, you have, I would use, for example, Stack Overflow. You can ask LLM, but never ever outsource your thinking to LLM. You are not coders, you are programmers. Try to use it to improve your learning. LLMs have that really nice capability that it looks like a good output. It only looks. There's a huge difference between looking good and being actually good. And it makes you feel productive. But one of the projects on which I worked, the client really loved using LLMs in a ways that were completely uncontrolled. We would create an API, and he would come overwriting entire API because it was easier for Claude to integrate with it. Don't do that. Be respectful of your engineers' work and time they put into. Now, are LLMs good? I do not know. They are helpful with the small things, but what I have seen in my experience is that people really have no sense of control with them. They think it's a magical bullet. It is not. It will not rewrite your code base. Like when you're refactoring, you can use it to figure out small things. It will not magically solve all your issues. So be kind to your coworkers. Be kind to yourself. Try to learn stuff from LLMs, not give them to work your entire job. It's hard when we have deadlines and everything, but make time for yourself. And lastly, I want to thank you for being such a great audience. We can take questions now. Yes.
Hello, thanks for the talk. I do not talk or program the multi-field parts. My question is, how do you go around refactoring or updating the larger code base and justifying it to management in a way that, because what I found out is I can either take the whole thing and redo it, or I can do small parts, right? But if I do the small parts, then I end up with a code base which is kind of completely both, right? With a bunch of old code and a bunch of new code. So how do you balance between these two things?
Ideal scenario is to refactor everything, because the old code base is old for a reason. But it sadly happens very rarely, because changing entire code base is not something that managers will like to commit resources to. So make compromises, make it the best as you can, and in your new code, underline, like make comments, so like what you would like to change in the future, document everything. Because, okay, you got a small piece of the code. You may get approval for it later. So when you come back, you don't have to put all the effort that you put earlier. Like, I really wish there was a way to make management say, let's make it as good as it should be. I have not seen it in practice. More questions, don't be shy. Yes?
So you said, thanks for the talk, by the way. So you said to anticipate the questions of management, for example, what is the benefit? So I wanted to ask, what's your usual answer to get management to approve the additional time?
I tell them how much money they're going to make. Like, if you have something in production, you can go and take a look. Okay, this is taking 1 hour. We are spending this much per EC2 instance. If we can improve the number of requests they are serving, then magically, if we can serve 30% more requests, we're going to make 30% more time. It does not work like that, but management really likes numbers, some estimates. They really love money. That's the most practical advice I can give you. Yes?
How do you balance between a small PR and a PR that adds functionality? When do you know it's too small?
I don't think there is such a thing as a too small PR. Like if it's improving code base, even if it's just one line change, commit it. Like if it's small PR, it's going to be fast to review. Make PRs. Like don't be shy to improve the code base. It might be too small now, but those small efforts accumulate over time. You avoid having to do lots of work. Yes?
Thank you for your talk. Question about testing. You had mentioned mocking. Are there times when you just use mocks to write a test before you make a refactor, or do you always test the black box as well?
I usually start with a black box. I try to test my hypothesis without going too deep into the code, because that entire black box is what you're trying to change. And if you start testing it inside, it's going to make your final change, like the design that you want to have, much more harder. It calcifies it, and you try to follow the previous design. So test the black box, test it as much as you can, and then everything inside it you can easily change. And as you work, start adding tests around the smaller parts until you get to the unit tests.
Thank you.
Ooh. Yes?
I'd like to know what you think about applying template in the code. So for example, with the templates, we know exactly which function should be located in which part of the code, in which folder, for example. What do you think about that? For example, connection with the database can be one folder, or all the calculations can be in another folder. Does it help to for refactoring readability of the code, or what do you think? What is your experience?
Well, usually I like to keep it separate, but sometimes you just group things up together. It depends on your team and what is the most logical and readable to them. If all the other projects are done in a certain way, you're probably going to follow that convention. But more granular, more you separate things, easier it is to change just that one layer. Have I answered the question? Somewhat. Okay, let's talk afterwards. Anything else? Oh, then I have answered all the questions. Thank you once again.
Thank you very much.